There are various erosional landforms found at the coast. We've already looked at Old Harry, which is our rock stack. There you can see Old Harry as a stack sticking out at the end of the headland. But there are other erosional landforms as well, such as coves, and Lulworth Cove is found on the south coast in Dorset, along the Jurassic coast, which is the area we've been looking at. But we need to delve in to find how it's formed. Ourselves of the erosional processes that are at work. There are a few main erosional processes at work along the coast. We've got abrasion, and abrasion is where the rocks are thrown at the cliff by the waves. So the waves pick up the sediment, pick up pebbles and rocks off the beach, they throw it at the cliff, and as they do so, they wear away parts of the cliff, creating a wave-cut notch at the base. We've got hydraulic action. Hydraulic action is the force of the water, and what happens here is the waves force air into cracks in the rocks, increasing the pressure and breaking little bits of rocks off. And again, that creates a wave-cut notch at the bottom of the cliff. Attrition does not erode the cliff. Attrition erodes the sediment. So this is where sediment that is rolling around in the sea or along the beach may be quite large, and then as it hits each other it becomes smaller and more rounded. And finally we have corrosion. Corrosion is where the acids in the water or the water react with the rock to dissolve the rock, and again it will wear away the cliff and the pebbles within the sea. So here's Lulworth Cove along the Jurassic coast in Dorset. There it is at the bottom, and there's Old Harry as well. Old Harry is here just off Studland Bay, and Lulworth Cove is on the south coast area there. So if we zoomed in and had a look at Lulworth Cove to see how it's formed, there are a couple of things that we need to notice. There's a little narrow entrance where the sea is eroded in, and then it widens up into a bit of a bowl shape. And if we were to look at that in plan view, we would see that this area of hard rock next to the sea, and then behind that harder rock that I'll draw in red, we have a softer rock. And what happens is the sea will find a weakness within the hard rock, within that Portland stone. And the sea will find a weakness and it will erode through a small crack within that area. But as it erodes a small crack through there, it hits the chalk. And when it hits the chalk, the erosion there speeds up. So we end up with a small, narrow gap where the sea has broken through the hard rock. But then the erosion opens up into a wider cove through the soft chalk rock. Lulworth Cove has been forming over the last 10,000 years, and that's how it's formed. We've got this small crack within the Portland stone, this hard rock, and then that stays quite hard on the outside, but then the water erodes the softer rock on the inside to create this cove shape. Of course, we need to remember that the methods of erosion that this will use to erode the cliff are abrasion and hydraulic action. It will not use attrition, because attrition only makes the sediment smaller and more rounded. It is abrasion and hydraulic action which do the erosion. Hydraulic action, of course, we remember is the force of the waves, and abrasion is the force of the rocks that hit the cliff because they're being thrown by the waves. And Lulworth Cove is what we call a concordant coastline, which means that there is one layer of rock that is parallel to the sea. So there's the Portland stone, and then behind it in green, that's where the chalk area is. It's concordant because there's this one layer of rock that is next to the sea. Concordant coastline. The spelling for that, concordant coastline.